Wanted to talk about temperature today, and this is the Fahrenheit scale and the Celsius scale. The Fahrenheit scale, as I've told you before, is based on body temperature being about 100. They chose somebody who was a little bit on the hot side. And 0 being the salt ice bath that one would normally use to make ice cream on a summer day. It's approximately 0. But both of these are not very good standards. Celsius chose standards that were a bit better. The boiling point of water on at sea level was chosen to be 100 out here somewhere, and the freezing point of water was chosen to be 0. Again, 100 degrees between the two standards. Anyway, that's why the Fahrenheit standard looks kind of funny. The only country in the world to use Fahrenheit degrees is the United States. The rest of the world has gone to Celsius. Now, we talk about a unit conversion factor. There's between the boiling point of water and the which is at 100, and the freezing point of water is 100 degrees Celsius. That's also 212 in Fahrenheit to 32. That's 180 degrees. So you've got 180 degrees Fahrenheit for every 100 degrees Celsius. Let's write it here. 100, let's increase this to 24. You got 100, let's see, the lowercase 0 we can make into that, and then we get out of that. 100 degrees Celsius is equal to actually, it's not 100 degrees Celsius. It's a difference of degrees. So the span of 100 degrees Celsius, and so we could do insert. Where's symbol? Symbol. And the symbol we want is Greek. Okay, let's go down here to symbol. Yeah, right there. Okay, so a change of degree C of 100 degrees is equal to a change of 180 degrees Fahrenheit. So that's the size of the degrees. The problem, the reason why I inserted the delta for difference is because the zeros of the scale are different. That's different than most other things that we deal with, like mass or length. If you got 0 length, it's 0 whether you're talking about centimeters or feet. If you got 0 mass, it doesn't matter if you're talking about kilograms or milligrams. It's still 0. But with the Fahrenheit and Celsius temperatures, it's different. Their zeros are at different places. And so the way we do this is we then take, let's say that we've got a temperature, like human body temperature, 98.6. And let's capture this. Copy. It's not letting me copy. Copy. Paste. Okay, let's say we start with human body temperature as it's normally stated. It's too many significant figures, but that's okay. To make another scale that's just like Celsius that starts at the same temperature, we know that the freezing point of water occurs at 32 degrees Fahrenheit. So we minus 32 degrees Fahrenheit. Okay, well, that's a number that's going to be in Fahrenheit degrees going from 0 at the same place Celsius would be. So then we would multiply that by a unit conversion factor based on this these temperature spans. The temperature span of 100 degrees Celsius is equal to a temperature span of 180 degrees Fahrenheit. But we've got Fahrenheit in the numerator here, so that's going to have to be in the denominator of the conversion factor. So you got 100 for every 100 degrees C. Copy. Paste. We've got 180. Paste. Degrees F. Normally, they just express this. Now, of course, the F's are going to cancel out. Let's see. We're going to go here. Go strike through. Okay. Strike through. Okay. And strike through. And so what we're going to end up with is a temperature in Celsius. So let's pull up the calculator and actually do that. So let's see what we got. Calculator. All right, so we've got 98.6 equals minus 32 equals. And now we're just going to call this 1.8. It's going to be divided by 1.8 equals 37 degrees Celsius. So all the rest of the world knows that the human body temperature is 37 degrees Celsius. Since all these other numbers are exact, the 32, the 100, the 180, if you were making this correct, if this was the correct number of significant figures, then the number here should be 37.0. Turns out it's the other way around, and we really don't know human body temperature to that precision. But following the rules, that's what it would be. Okay. Let's look at the scales now. The scales do an integer number of Celsius degrees equals occasionally it equals an integer number of Fahrenheit degrees. So here's some examples. So we start from 0. You add 10. At 10 degrees, it's 50 degrees Fahrenheit. 20 degrees is 68 degrees Fahrenheit. And this used to be the laboratory standard, 20 degrees. But now it's 25 degrees, and 25 degrees is 77 degrees Fahrenheit. So similarly, 37 is not an integer number of Fahrenheit degrees. 37 is, of course, 98.6. 40, a lot of places are recording degrees of 40 degrees or more. Celsius, which is 104 degrees. And finally, you've got the boiling point of water. 100 degrees Celsius, its Fahrenheit is 212. Of course, this is only the boiling point of water at sea level. As you go higher and higher in the mountains, the air pressure drops, and so does the boiling point. And those are the highlights I want you to see. We also talked previously about minus 40 being the same between the scales. And that, I believe, is that. Okay, here's what we just did. Is Fahrenheit degrees, some number. They didn't put an X there. But X Fahrenheit degrees minus 32 divided by 1.8 is equal to Y Celsius degrees. And you can use your algebra to reverse that. Kelvin, which is the absolute scale, here it is, at 0 degrees C is 273. It's actually 0.15. And so you just add that to the Celsius temperature to get it, 273.15. And so Celsius being 100 degrees at the boiling point of water at sea level, it would be 373.15. That's all you need to know about that. So let's close this. Thank you very much.